Alright, this last complication looks like this. And the complication is in the bottom here we have a factor that is used more than once. We call it a repeated factor. So when we have that situation, we actually will set up our partial fraction a over x minus 1. So that's probably not surprising. But when we get to this, we need to use first this factor appearing once in the denominator, and then we're going to use it appearing twice in the denominator. So that's a little different. So let's see how the a, b, and c will work out. I'm going to do this one a little differently. I'm going to start by multiplying through and clearing the denominators, multiplying by the greatest common denominator. So that's an x minus 1, an x minus 2, and an x minus, oh, I can put those together. If the greatest common denominator is x minus 1, x minus 2 squared. So that will gather all of our denominators and leave us no denominators when we multiply through. You can always tell if you got it right if you end up with an expression with no denominators. So let's see if that happens. When I multiply this times this, these cancel, leaving just the 6x squared, the negative 19x, and the plus 15. When I multiply this times this, the x minus 1's cancel, leaving an a and an x minus 2 squared, quantity squared. And the b will give me a x minus 1, but only one of these x minus 2's cancel, leaving the other. And then here, both of my x minus 2's will cancel, leaving me a c times an x minus 1. Alright, as I said, I'm going to teach this one a little differently. So on the left, I'm going to leave that. When I get to the right, I'm going to actually multiply this out, which I didn't do on any of the others. So I know this is x squared minus 4x plus 4. So I'm going to distribute the a right now to all of those sort of combining steps. And see if you can see that well. All right. Now the b, I know this times this is x squared minus 3x plus 2. So I'll distribute the b to that, combining steps. And then distribute the c, cx minus c. Now, on this side, again, I'm not going to do anything different for a while. And now I'm going to gather my x squared terms. So there's only two of them. And I'm going to pull the x squared out of these two terms, and it leaves an a and a minus 3b. Oops, sorry. Looking at the wrong term. I'm going to, when I pull out, I guess I pull out an x squared from this term and this term, it leaves an x squared and an a plus b. So pretending these terms were side by side, I pulled out an x squared in front and it left an a plus b. Now I'm going to do the same thing for the terms with an x in it. There's 3. So if I pull out an x out of those terms, it leaves a minus 4a out of that term, factoring it out, a minus 3b out of that term, and a plus c out of that term. Alright, and lastly, I'm going to gather my constants, ones with no x values. So I have a 4a, a 2b, and a minus c. So I'll just kind of put them in a group, and I've lost you. So when back here, I pulled an x out of those terms that had an x in them. So just regrouping. So I pulled out an x out of the minus 4ax term, and I pulled an x out of the minus 3bx term, and out of the cx term. And that's what it looks like when I grouped those together and factored out an x. And then the constants that were left without an x term or 4a, 2b, and a minus c. All right, so you might say, this looks like a lot of work, but we're pretty much home free now. The only way this expression can equal this one is if the number in front of the x squared term here, which is a 6, come back into view, which is a 6, equals the number that's in front, or in this case behind, this x squared term. So I know that this 6 here, is that showing up or is the light funny? This 6 has to equal that because the x squared term has a coefficient of 6. So this x squared term must also have a coefficient of 6. So I'm going to just say 6 equals a plus b. I'm going to do the same thing with the x terms. So the x term here has a negative 19 coefficient. Over here, the x term has this coefficient. So the only way these two expressions could be equal is if the coefficients of the x terms are equal. So I'm going to grab the negative 19 from here and the negative 4a, negative 3b plus c here. And lastly, the only way these two expressions can be equal in the last step is if their constants are equal. So this is the constant term, and over here the constants are 4a plus 2b minus c. All right, so you say, well, that looks like a sloppy mess. We have all these unknowns and numbers, but I noticed very quickly that if I add these two equations, we will have a lot of dropouts. So the negative 19 and 15 is a negative 4. And this will drop out, this will drop out. A minus 3b and a positive 2b gives me a minus b. So then I can multiply through by a minus 1, and I get very quickly that b equals 4. All right, so I know up here, if b equals 4, I can go right up here and see 6 equals a plus 4. So if 6 equals a plus 4, I can subtract 4 from both sides. I get a equals 2. And now I need an expression with c in it. So I can take either of these. I'll take this one. So I get 15 equals 4 times a, but I know a is 2. And plus 2 times b, but I know b is 4, minus c. So I'm right up to there. Solving that for c, I get an 8 and 8, so that's 16. Move the 16 over, it becomes minus 1. And then multiplying both sides by 1, I get c equals 1. So instead of rewriting everything, I'm going to borrow these numbers. A is 2, B is 4, and C is 1. So I'll go back to the original and just use the old eraser. So the eraseroo trick to save us a little bit of video time. All right, so as I said, A was 2, B was 4, and C was 1. So that's another method for using, you could use that method on any of the ones we've done so far, or you could use the method let x equal 2, let x equal 1, and solve it that way. The final answer is right here. This is the partial fraction rendition of this. All right, I hope that the giraffe knew that you would follow and be proud of yourselves for learning partial fractions. So on the snowy evening, it's Friday very, very late, about to be Saturday. I am over and out. Goodbye.